Yeah, good day viewers. In this video tutorial, I'm going to teach you how to apply pressure volume work. When we talk about work done, which work done in terms of what pressure volume work in thermodynamics. That was called in fluid or thermodynamics. Look at the question. But if you have not subscribed to this channel, if you are new to this channel, please subscribe to enable me grow my channel. Thank you. And after you have subscribed, turn on the notification bell so that anytime we post a video, you receive a message. Also, like and share to your friend. Thank you for doing that. Let's look at the question. A fluid in a cylinder at a pressure of 750 kilonewton per meter squared. Full stop. It is expanded at a constant pressure from specific volume of 0.12 meter cube per kilogram to a volume of 2.31 meter cube per kilogram. Full stop. What is the work done? What is the work done? And when we look at this question, they said a fluid. Fluid can be a gas, can be liquid, can be what? Any type of liquid is called what? Fluid, which can be any type of gas. So we said a fluid in a cylinder at a pressure of 750 kilonewton per meter squared. That's the pressure. Then now what they told me here is that it expands at a constant pressure. For this to expand at a constant pressure, that means is what? Isobaric process. That is what? Isobaric process. For us to get a constant pressure system, that means that system is in what? Isobaric. We said constant pressure from specific volume of this. And what do we call specific volume? Specific volume is a volume of a unit of mass. A volume of a unit of mass. That's a unit of mass of a what? Fluid can occupy. The volume which a unit of mass of a fluid can occupy is what we call specific volume. That means specific volume is a volume which a unit of mass, 1 unit of mass of that what fluid can what occupy. That's why it's given in what? Meter cube per kilogram to this. Then what is the work? Then for us to go to the work, I look at solution. Let's also look at the work. We look at this piston. Look at the piston. For me to break this piston down, I need to apply pressure here. If I apply pressure on this piston, I have to move in from the volume, the first volume to the last. That means I sweep this piston through this area. And the distance I will cover from here to here is what? L. And I know that work done, which we call mechanical work done, which we call mechanical work done, is equals to, work done is equals to what? Force. Force times what? Distance. Force times distance. And this force, distance in the direction of force. Distance covered in the direction of force. We said work done is force times distance covered in the direction of force. Then now looking at this is what we call mechanical force. Then let us look at this mechanical force in terms of what? Pressure volume work. Then I look at it. For me to break this piston down, I have to apply pressure here. I have to apply what? Pressure down. Forcing this piston to sweep through an area. I will not say that what? Pressure, look at the pressure, is equals to what? Force over area, over area. Which means that what? Pressure P is equals to what? Force over what? Area. Then making the force subject to formula, I will say that force is equals to pressure area. That means my force is equals to pressure times what? Area. That's my force. Then now, carrying this particular value to put into work done. You remember work done, which we represent with W. W, omega W, is equals to what? Force times what? Distance. And what is distance? Distance in these terms is what? L. Distance. L. D. Then, taking this PA to replace my what? Force here, I will have that work is equals to what? P times area times what? Distance. And what is distance? Distance is something as what? L. I have this W is equals to P A times what? L. Then that L becomes distance, or D distance, L distance, D distance. Then now L times area will give me volume. That's give me P area times what? Length will give me what? Volume, which is what? V. Then now work done will not be what? Work done will be equals to what? Pressure times difference in volume V2 minus what? V1. That's me moving from V1 to V2. That's what? Change in volume. Are you getting what I'm saying that? Therefore, I cannot say that work done is equals to what? P D V. Are you getting what I'm saying? That's work done is equals to change in volume, which is what? dV. Change in volume from volume 1 to what? Volume 2. As I'm pressing this piston, I sweep this piston through what? An area of this. Or sweep this piston through what? A volume of this. I'm pressing this piston with my what? Force. Pressing the piston down. I'm sweeping this piston through and what? A volume from 1 to 2. That means change in what? Volume. And this is what we call pressure work done. Pressure volume work done. We now have P equals to what? This V2 minus what? V1. And that's the pressure volume what? Work. I call it what? Pressure volume what? Work. Why these are called mechanical work. And this is what? Mechanical work in terms of what? Pressure volume. This one mechanical work in terms of force times distance. Why this is mechanical work in terms of what? Pressure volume. Then let us go to the what? Question. Now using the formula which we call work done. Now using the formula work done, which is pressure work done, W equals to pressure change in what? V2 minus what? V1, which we are not confused about. Then I have that my what? Pressure P is equals to, pressure was given to me as 5750 kilonewton per meter squared, and that will be, this is kilo, that's give me what? 750,000. That's kilo stand for 1000. I'm going to multiply 750 by 1000, give me 750,000 Newton per meter cube. Then I have the volume V1. I have my V1 to be equals to, my V1 was given to me to be what? 0.12 meter cube per kilogram. This is called specific what? Volume. Then let me get the volume. This specific volume, then when I say volume actual volume become equals to 0.12 meter cube per kilogram times kilogram. That's 1 kilogram. This is per kilogram, means this is 1 kilogram. The volume of 1 kilogram can what? Occupy. The volume of 1 kilogram of the fluid can occupy this times 1 kilogram, and that will cancel. Kilogram cancel kilogram. That give me V1 is equals to 0.12 meter cube. This is the actual volume. Then V2, I have my V2, and my V2 is given to me as 2.31 meter cube per kilogram. That's a specific what? Volume. Then for me to get the actual volume becomes V2 equals to 2.31 meter cube per what? Kilogram times kilogram over 1. This is over 1. You remember, this is over 1. Anything written is over 1. Anything written is over 1. You remember what we said? Anything we write is divided by 1. Then multiply this through. This will what? Cancel. I will have my V2 is equals to what? 2.31 meter cube. That's my actual volume. Look at my actual volume. Look at my actual volume too. Then I'm going to look at the work done. Work done, work equals to what? P into what? V2 minus what? V1. That's work done. Substituting the value, I have W equals to what? The pressure given to me is a what? 750,000. 750,000 into the V2 is 2.31 minus V1, which is what? 0.12 in brackets. And that will give me W equals to what? 750,000 times 2.19. 2.19. 3, removing 3 here, that give me 3112. That give me 10. Removing it here, 1 here, put in here, give me what? 10. That will give me 8. I get what I'm saying now. That will give me 8. That's 11. I mean to say, taking 1 here, put 11 minus this will give me 9. Here will give me 1. That's 2.9. Multiplying this with your calculator. Let's use our calculator. 750,000 times 2.19. That'll give me 164,250 Newton per meter squared, Newton per meter squared. And remember, note that 1 Newton meter squared is equals to 1 joule. There is 1 Newton meter squared is equals to 1 joule. Therefore, this is equals to 164,250 joule. That means this 2500 what? Joule. And that's give me my what? Answer. That's 1 Newton meter squared is equals to 1 joule. That means this is something as what? Joule. So when I have this our what? Answer. That's what we have for you today. If you love what we are doing, please don't forget to subscribe to enable me grow my channel. Thank you.